Hi folks, welcome back. I hope you're all doing well. Today I want to take a look at a paper that talks about natural language guided programming, and what that means is using some sort of a machine learning model to autocomplete or suggest code based on a short natural language description of your intent. There's this common but probably true programming trope that all programmers copy and paste from Stack Overflow and then edit their code to match their local context. And what the authors here are trying to do is more or less automate that. They want some sort of autocompletion that looks at the local code that the programmer has already written, but also a natural language specification for their intent of the code that they want to write next. Now, obviously, this is a very challenging task in general, and the authors here are tackling one very specific domain, which is data science, and a specific language, which is Python. When we speak of AI-assisted code completion, it's naturally going to raise comparisons with existing systems like Tab9 or the more recently announced GitHub Copilot, except that those are closed commercial systems, and to the best of my knowledge, there's no publicly available documentation about their inner technical workings. This is a quick example of how the system works. Here you have a short Python code snippet for reading in some data from a CSV and then using the pandas library to do a group by country on that data. And then you type in this comment stating your intent for what you want to do next. You want to filter by last month. And this is where the assistant kicks in and suggests to the programmer these lines of code that he can pick from. And here you can see a few more examples where you provide a comment for what you want to do next, and the NLGP assistant serves up some suggestions. As you can see, it's pretty fluent with basic pandas operations like adding new columns or grouping data or charting it and so on. So how does this work under the covers? The authors here are using the well-known GPT-2 pre-trained model that was released about a year ago. And that model was trained on general purpose English text. Now you want to extend that model and train it to autocomplete code, but based on a natural language input. And this is something it wasn't trained for. So we have to find some data to train the model to do this. The data set that the authors chose were GitHub projects that contain Jupyter notebooks. And this gave them about 300,000 notebooks to train on. And then they massaged that data set in 3 different ways to train 3 different language models. The first one was one where they stripped all comments. Now, obviously, this isn't going to be very good because the whole point of this model is to predict code from a comment. So this is only supposed to be a baseline so that we can figure out what the contribution of natural language comments to the prediction accuracy is. The second data set was synthesized by taking call sites for a particular API method and then inserting comments from that method's docstring just before the method call. And finally, we have the third way in which they trained, which was just to use the naturally occurring comments that were already in the code. You also need to account for things like how do you train the model to predict source code instead of just completing the comment with more natural language. And here they picked the simplest thing that could work, which is they annotate the code with these special tokens that mark the end of a code cell or the end of a comment. And when making predictions, they cut off the prediction at this marker that indicates the end of a cell. And finally, to measure the results, the authors did a study with human programmers and measured 4 different criteria. The first one was usefulness, which asked whether the predicted code was helpful for implementing the given intent. Then we have coverage, which measures whether the predicted code completely covered the intent. We have precision, which measures whether the predicted code was relevant to the intent or whether it contained other spurious code. And finally, we have compatibility, which asks whether the predicted code was compatible with the already written code around it. For example, whether it used the same variable names. And here you can see, obviously, the model which used no comments doesn't do very well at all, but the other two, the one which used docstrings as synthesized comments and the one that uses the naturally occurring comments, actually fare pretty well on all of these criteria. So this is still pretty initial work. The authors picked a very specific domain with one single language to kind of show the feasibility and the promise of this idea, but are mostly just trying to show us that there is something worthwhile to investigate here. So that was a quick look at how one might use AI models to autocomplete or generate code from a natural language starting point. I hope you enjoyed that, and I will see you next time. Thank you very much.